In July 2025, scientists hurrying to monitor a fresh interstellar comet anticipate merely a fleeting celestial streak. Yet the discovery that unfolds challenges every established principle. 3I/Atlas deviates sharply from norms, failing to trail its tail outward from the Sun, as all previous comets have done. Rather, it emits a targeted stream directly at the Sun, generating a reliable thrust reminiscent of a concealed motor in operation. Its composition feels otherworldly, its trajectory strikingly exact, and its velocity, 135,000 miles per hour, compels specialists to reassess their understanding of intruders from outside the solar system. If a comet can mimic engine-like propulsion, an outcome deemed unattainable, then precisely what is 3I/Atlas? And why does its tail pointing sunward unsettle researchers so profoundly? On July 1, 2025, the Atlas Observatory in Rio Ardo, Chile, detected an anomalous in motion that matched no known records. Almost immediately, the system's automatic notification alerted its handlers. The entity was hurtling through the heavens at 61 kilometers per second, equivalent to about 135,000 miles per hour, along a route incompatible with any native solar system object. Communication channels buzzed with activity as initial orbit calculations emerged. The figures were unequivocal. This was no orbiting comet circling the Sun. Its path formed a hyperbola, with eccentricity well beyond 1, an unbound arc, the hallmark of an extraterrestrial visitor. Historical scans from the Atlas and Ziki transient surveys in mid-June unearthed subtle hints, solidifying the confirmation. Every additional measurement refined the profile, approaching from Sagittarius and cutting across the solar system only 5 degrees from the ecliptic plane. The accuracy left the group astonished. Typical comets drift in from the Oort cloud at speeds seldom exceeding 50 kilometers per second. This one outpaced any recent comet on a trajectory set to pass between Earth and Mars by late October. Harmless to our planet, yet utterly compelling. What started as a standard find escalated into an international watch. Soon, facilities on 3 continents scrambled to snag updated photos ahead of dawn. The designation settled on 3I/Atlas, marking the third verified outsider from past our Sun. Time pressed on, and each fresh image suggested an unforeseen narrative. By July 21, 2025, Hubble's photo experts convened for a routine review, anticipating verification of a conventional comet narrative. But the unprocessed shots unveiled a stream bending right toward the Sun, a tight, enduring solar jet. The expected anti-solar tail lingered weakly, barely noticeable. Data from Gemini South corroborated the alignment. Experts scrutinized for glitches, adjusted instruments, and cross-referenced against the Gaia Stellar database to eliminate stellar interference. The stream remained firm through multiple shots, its form unaffected by shifts in perspective or solar wind variations. Positioning squads, leveraging Hubble and Gemini's superior resolution, charted the body's shift relative to fixed stars. The readings defied conventional trajectories. Successive location fixes indicated a slight, yet steady shift from pure gravity's influence. An added acceleration of approximately 4 times 10 carat -7 m/s superscript 2. This boost aligned perfectly with the sunward stream. Not erratic venting or erratic sprays. The impulse was focused, ongoing, and synced with the evident jet. Theories relying on radiation pressure couldn't explain it. For fine dust particles, solar rays ought to drive the stream away from the Sun, not into it. Sustaining such a jet demanded bigger, denser particles or an unprecedented mechanism. The outcome, an entity seemingly propelling itself toward the Sun, powered by an invisible drive. For those handling images and measurements, the findings posed a puzzle beyond current physics. What mechanism could produce a comet tail acting as a thruster? Specialists in jet modeling at the University of Maryland crunched the figures for the sunward stream. To replicate the detected acceleration of 4 times 10 carat -7 m/s superscript 2, the body would require mass ejection exceeding 300,000 kilograms per second. That's propulsion akin to a modest rocket, not a natural ice ball. In reality, photometric and spectral analyses peg dust and gas release at 0.1 to 1 kilogram per second, The discrepancy is immense. Even assuming all plume particles launched at maximum velocity, the visible output lags by a factor of 10,000 or more. No local comet exhibits such a disparity. JWST's spectrum analysts, under Dr. Carey Liss, probed the surrounding haze's makeup. The readings revealed carbon dioxide dominating water at an 8-to-1 ratio, flipping the standard comet blend. Even more startling, nickel atom signatures surfaced without accompanying iron. Here on Earth, nickel and iron typically coexist in meteoroids and alloys alike. In 3I/Atlas, nickel appears isolated. The group re-verified instruments and aligned with laboratory benchmarks. The indication persisted. All conventional explanations, sublimation, gas flow, projectile release, fall short in explaining the discrepancy. The enigma surrounding 3I/Atlas grows more intricate with each revelation. Should the measurements hold true, an unseen influence appears to be propelling this interstellar interloper sunward with a propulsion unlike anything observed in natural phenomena. Researchers at Harvard's Orbital Dynamics Group inputted the updated path into their Monte Carlo simulations, executing countless virtual scenarios of objects entering from deep space. The probability of a haphazard visitor approaching merely 5 degrees from the ecliptic plane, sequentially bypassing Mars, Venus, and Jupiter, registered below 1%. Typically, such cosmic wanderers plunge in at steep inclinations, arcing over or under the solar system's planetary plane. Yet in this case, all principal worlds except Earth align neatly with its route. Experts who previously scrutinized the 2017 Oumuamua irregularity re-entered the discourse, highlighting how that pioneer also clung closely to the ecliptic, though sans the thrill of close planetary passes. Oumuamua exhibited its own baffling speed-up, yet lacked any coma or outgassing, merely a quiet, rotating fragment. By comparison, 3I/Atlas announces itself boldly via a distinct, organized jet and a course that seems deliberately plotted. SETI enthusiasts and experts in celestial mechanics clashed over the ramifications in draft papers and nocturnal online forums. A few dismissed the sequence of planetary grazes as mere astronomical happenstance, a rare fluke amid universal chaos. More speculative minds pondered if the trajectory forms an integral message, perhaps a crafted display or probe to gauge if observers are attentive enough to detect it. The impending solar occultation heightened the pressure on each fresh computation. Should the orbit alter post-conjunction, it would mark the inaugural genuine essay of deliberate agency. For now, the intruder's unlikely trajectory poses both a riddle and a provocation, mere fortuity, or is an entity purposefully steering through our stellar domain. October 30th, 2025. As 3I/Atlas slips into the sun's glare, observatories worldwide, both terrestrial and spaceborne, confront an inevitable data void. The intruder will vanish amid solar luminosity for several weeks, undetectable by even the finest detectors. NASA's planning crews and Earthbound observers synchronize their concluding observation sessions, hurrying to seize the final glimpses prior to alignment. Backup strategies proliferate. Neither boundless resources nor clever innovations can span this void. The influx of information will cease, creating a critical gap precisely when the body attains its closest solar approach. To those overseeing the pursuit, the peril is evident. Any deviation in velocity or heading within this period will evade notice. Humanity pauses in anticipation, yearning for 3I/Atlas to emerge from the far side. With global scopes going dark, conjectures proliferate unchecked. SETI proponents argue whether 3I/Atlas embodies a Bracewell von Neumann craft, a self-sustaining watcher primed for intelligent signals. Alternative views cite the CO2-laden, nickel-heavy emissions as signs of intentional release, akin to seeding worlds with adaptive materials. Certain interpreters cast it as a galactic intelligence puzzle, its anomalous propulsion and precise alignment designed to spotlight rule-breaking physics. The most ominous theories summon images of interstellar war remnants, shattered hulks adrift with malfunctioning drives. Consensus emerges on a single point. Resolution awaits beyond the eclipse. Comets' December 2025 return, If 3I/Atlas's path strays past gravitational forecasts and established physical laws, the controversy will escalate dramatically. In the interim, all projections and hypotheses remain in limbo. Intricate simulations indicated the documented material ejection fell short by a factor of 10 to account for the anomaly. Even as JWST's readings uncovered an atypical CO2 to water proportion of 8:1, alongside nickel-absent typical iron companions. Should the course diverge from solar gravitational expectations, discussions on organic versus manufactured provenance will intensify. At present, 3I/Atlas endures as the most confounding extrasolar arrival in history, appending core notions of astronomical events.